today we are going to look the exercises from the first chapter of Maths, that is number system. And before moving on to the topic, let us look the thought for the day. And the thought for the day is push harder than yesterday if you want different tomorrow. Push harder than yesterday if you want different tomorrow. This thought means that you have to do better than the previous day because the competitions are becoming tougher. Okay, so now let's move back to our topic, and we are going to look at the exercises from the first chapter as we said earlier. And we are going to look at the exercise 1.1, and here I have written the first question from the exercise 1.1, and the question is 0 a rational number? And can you write it in the form of P by Q, where P and Q are integers and Q is not equal to 0. So, and what do you mean by rational numbers? Rational numbers means the numbers which are in the form of P by Q, where P and Q are integers and Q is not equal to 0. So that is rational number. And here the question is 0 a rational number, and can you write it in the form of P by Q, where P and Q are integers and Q not equal to 0. So is 0 a rational number? Of course 0 is a rational number, and we can write in this form. So here, yes, 0 is a rational number, and also we can write in the form of P by Q, right? For example, let's say 0 by 1. This is in the form of P by Q, right? And both are integers, and also Q is not equal to 0. And another example is 0 by 2. Then even though you can write this 0 with a negative integer, okay, a negative number, that is 0 by minus 15. So it goes on. So 0 here is a rational number, and 2 you can write in the form of P by Q, where P and Q are integers and Q not equal to 0. So that's the first question. Hope you understood that first question. Now let's look the second question. Now the second question from exercise 1.1 is find 6 rational numbers between 3 and 4. Find 6 rational numbers between 3 and 4. So there are infinity of rational numbers between 3 and 4, and now let's look one of the method to find 6 rational numbers. Okay, in between 3 and 4, let's take denominator as 1. Every rational number has denominator as 1, and 3 by 1, and we have 4 by 1. Okay, 3 by 1 and 4 by 1. Now we have to multiply the numerator and denominator of both these numbers with 7. That is, here we have to find 6, right? So we have to take the number. The number which should be multiplied should be greater than this number. Okay, the number in the question. So we have 3 by 1, and we have to multiply 7 to both the numerator and denominator, and we have to find the answer solution, that is 21 by 7. Then 4 by 1, again the same method. So we have to multiply numerator and denominator by 7, and we get 28 by 7. So this is how we have to find the rational numbers between 3 and 4. Here we have got 6 rational numbers between 3 and 4. Let's look. The answer is 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, and 27 by 7. So we have got 6 rational numbers between 3 and 4. So 1, 2, 3, 4, 5 and 6. 6 rational numbers between 3 and 4. This is how you have to find rational numbers between the given numbers. Okay. So firstly I just recap the process, the method. That is, you just have to write 3 and 4 and you have the denominator as 1. And you just have to multiply a number which is greater than in the question, that is 7. And you have to multiply that 7 with both numerator and denominator of both these numbers. And you get the answer. And here is the 6 rational numbers between 3 and 4. Hope you understood this question. Now let's move on to the third question from this exercise. So now the third question from the exercise 1.1 is find 5 rational numbers between 3 by 5 and 4 by 5. So you have to find 5 rational numbers between 3 by 5 and 4 by 5. And here the steps are just same. We have discussed in the question number 2, the steps are same. And you have to find out yourself. You just pause the video and you just solve this answer and come back to the video and you just look whether the answer you got is right or wrong. And let me know you how many of you have got the correct answer, and reply these answers in the comment box given below. And okay, you're ready? Yeah, your time starts now. You just pause the video and go and solve the answer. Okay, coming back to our video, let's solve it. You check whether your answer is right or not. Okay, here we have the question 3 by 5 and 4 by 5. 3 by 5 and 4 by 5. So the first thing we have to look is check whether the denominators are same or not. Here the denominators are same. So we have to find 5 rational numbers, right? Just directly go and multiply the numerator and denominator of both these numbers by 6. How it is 6? You have to take the number which is greater than the number given in the question. Okay. So let's solve it. 3 by 5. You have to multiply it by 6 and you get 18 by 30, and 4 by 5. Do the same process and you get 30 and here 24. So you have got 18 by 30 and 24 by 30. Okay, this is how you have to solve the questions like this, and the answer is 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. So these are the 5 numbers between 3 by 5 and 4 by 5. And suppose you are getting a number like this. Find 5 rational numbers between 3 by 2 and 4 by 5. So here the question is different. What is the difference here? The denominators are different. So how will you find the answer? It's just easy. You have to take the LCM of the denominator, that is 2 and 5. You have to take the LCM of 2 and 5 and you get 10 as the answer. So guys, now you have to solve this. You have to take 3 by 2 and here while we are doing this step we have to make the denominator same. So here you should get 10 as the denominator. So we have to multiply 2 with 5 and you have to multiply this 5 again here. Multiply 5 here and 2 into 5 you get 10 and 3 into 5 you get 15. So the answer is 15. Again you have to do the same process here also, that is 4 by 5. After doing this process you get the denominator as same. So here you have to get the denominator 10. So you have to multiply it with 2 and also the numerator should be multiplied with 2 and you get 8 by 10. So here we have got 15 by 10 and 8 by 10. So we have got 15 by 10 and 8 by 10. Now the answer here, you got 9 by 10, 10 by 10 and it goes on till 14 by 10. So you have got numbers between 3 by 2 and 4 by 2. This is how you have to solve the answers. Well, if you get a number like different denominators, then you have to solve like this. So hope you understood this. Hope you are clear with this question. That is from exercise 1.1 question number 3. And now let's look the fourth question. Now let's look the fourth question from exercise 1.1. And I think we have discussed these questions in my previous videos, and if you want to know those questions more detailedly, you may check those videos. And in that video I think I have given 5 questions and here I have only 3 questions. These questions are from exercises and the rest 2 questions are from the examples, and I strongly recommend you to look over those example questions and you may get the idea of this chapter. So now let's come back to the topic, and here we have the first question is, every natural number is a whole number. Every natural number is a whole number. So is every natural number a whole number? Of course yes. So this statement is true. Since this statement is true, since the collection of natural numbers, since the collection of whole numbers consists of all the natural numbers. So the statement is true. Why? Because all the collection of whole numbers consist of natural numbers. So the second question is, every integer is a whole number. Every integer is a whole number. Is every integer a whole number? No, not at all. So this statement is false. For example, let's take -2. This is an integer, but is it a whole number? No. So the statement is absolutely false. And the third one is, every rational number is a whole number. Every rational number is a whole number. So is the statement true or false? Yeah, we have discussed. So this statement is false because every rational number is a whole number. Every rational number cannot be a whole number. So it is false. And an example for it is 1 by 2. This number 1 by 2 is a rational number, as you all know, but this is not a whole number. So the statement is false. So hope you understood the questions, 4 questions from exercise 1.1, and you just work out all these questions, and as much you practice, you get the result. So I'll be coming in the next video. I'll be coming with exercise 1.2. So till that, stay tuned. This is Nanda signing off. Bye.